All right, we're going to look at some special right triangles as a mini lesson or a reteach um, in case you need it or in case you were absent. And so we have two types. The first type that we're going to be looking at is specifically a 45, 45, 90. These are the angle measurements in the triangle. So if you look at this first one here, we know that this box means it is perpendicular. So this angle is our 90-degree angle. And then we have a 45-degree angle and a 45-degree angle. So that's where this comes from. In class, when we did this, we labeled our legs. So our legs of a triangle are the sides that are not the hypotenuse. And our hypotenuse is always directly across from our right angle. So this is our hypotenuse. And so our legs will have the same exact measure. And that is because my 45-degree angle here is the same as this one. And so I'm going to use a different color. This angle corresponds to, if it works, this side, and this angle corresponds to this side. So if these two angles are the same, then these two sides also have to have the same measurement. So this is also an isosceles triangle, which we learned a few units back. So depending on what number would go in place of our x's here, for the hypotenuse, the pattern for a 45, 45, 90 triangle tells us that the hypotenuse has a length of that same number from these, whatever that number is, times the square root of 2. So if I move on to the example over here, I have one side labeled already. So this has a side length of 17. So if this has a length of 17, I know that this side has the same exact length, so also 17. And my hypotenuse, I'm going to take that same measurement from my leg, so 17, and then I'm multiplying that by the square root of 2. And I'm going to leave my answers just like that. So I have my side lengths for my second triangle. And then for the last one, it's getting a little different. So I still have a 45, 45, 90 triangle. This is 90, this one is 45, and I know all three have to add up to 180, so that means this is also 45 degrees. My side length here is congruent with this one. So if this side length has a measurement of 4 times the square root of 2, then this side length is also 4 times the square root of 2. For my hypotenuse, I'm going to take that same measurement that goes in place of like my x here, and then I still have to multiply by another square root of 2. So I have my 4 square root of 2 from my two sides here. Those are the same. And I'm multiplying by the square root of 2 again. I do want to simplify this. So to simplify it, I'm actually going to do it underneath. If I have 4 times the square root of 2 times the square root of 2, I can multiply my two numbers that are both underneath the square roots. So if I wrote it out, it would be 4 times the square root, and then under my radical sign, I would have 2 times 2. So this 2 is here, and then this 2 is here. Well, I know I can multiply 2 times 2, which is 4. So I have 4 times the square root of 4. And actually, the square root of 4 is a whole number. It's not a decimal. The square root of 4 is 2. So I get 4 times 2, which ends up being 8. So if I go back up here, yes, this is my side measurement, but I can simplify that to be 8. If I wanted to do a different one, I'm just going to do one at the bottom here. Let's say it looks like this. So I'm going to do it kind of upside down. And we're going to say this is 45 and this is 45 and 90. So I have a 45, 45, 90 triangle. If I had to label it myself, and I was given the freedom to do that, I can choose any number that I want for the side lengths for my legs. And I would start with the legs. So if I say 120 2. This has a side length of 102, if my pen works, which means this has a side length of 102 because those have to be the same. And my hypotenuse would have a side length of 102 times the square root of 2. So that's a little mini refresher on 45, 45, 90 triangles.